Thank you very much. It's a great privilege indeed to address you on this topic. I don't regard myself as an activist, and it's almost it's a sensitivity that I have. It's a sort of an acute sensitivity because I'm a person of science and I'm a person of observation and understanding. And I have had the unique privilege of being invited to join an organization that some of you may or may not have heard of, an organization known as Pugwash. And Pugwash was a Nobel, or is a Nobel Prize winning organization, and it was founded by a guy, Joseph Rotblat, who is the guy that invited me into Pugwash. And the significance of Joe Rotblat is that he's a nuclear chemist, and he worked with Albert Einstein on the Manhattan Project. And the Pugwash movement is something that I held very close to my heart because it was based on the Einstein-Russell Manifesto. So when they were learning how to split the atom, during the Manhattan Project, in a nutshell, it's a long and lengthy manifesto, but in a nutshell, what the manifesto said, at least it resonated with me, was that good science should always have a moral conscience. And the other take-home message is that just because you can do something, in this case, split the atom, doesn't mean to say that you should do something. So, in other words, good science must always be aware of its consequences. And if you apply that to the peer review world, a lot of scientists are sensitive to people's opinions about their work and their peer review process. Well, good science should never be afraid of peer review because good science should always welcome public scrutiny. So that's what I am. I'm a person of science, but I'm a person that has never been. Well, I've always had an uneasy feeling about being fettered into this particular silo. I'm a non-siloed person, and therefore, to some, I am considered a mongrel. And I always felt that I'm a bit of a mongrel. Coming from Africa, I guess I'm more of a hyena than I am a lion, because. But that's just what it is. So what my talk's going to be about today is I'm going to work off my notes so you can follow me if you want to there. It's going to just be a summary of my personal journey from early childhood to professional and ultimately to where I am today, a retiree, still with a lucid mind and writing a huge amount up about our transition to democracy because I was deeply involved in that process as well. And I'm going to talk about the joy of moments of discovery. There've been moments in my life that I've made discovery, and discovery has always been an absolutely wonderful thing, an exciting moment. And part of that was my discovery of Newtonian reductionism, and my even greater joy at discovering the work of René Descartes, a French philosopher, and his impact on Isaac Newton. In fact, I had the privilege at Cambridge of sitting under the tree. There's a famous tree at Cambridge, and I had the great privilege of visiting that. When I was doing my PhD work, and I felt a sort of sense of presence. For what it want of a better word. But then, of course, my even greater joy at learning of a thing called the KT boundary, which is a part of sedimentary geology. So see, I jump around. I'm interested in biology and geology and botany and zoology and all of these things. But then my sheer fascination at learning that our generation, I guess, was many of us. There are some younger looking faces here. I'm looking at Rod Kershey, who's like a young man. But some of you are apparently of my vintage. So the sheer fascination that we as a cohort are currently going through a geological transition of our own. There's a geological epoch currently unfolding, and I happen to be a proud member of this particular group of people. And I'm going to tell you a little bit about uranium isotopes as it applies to South Africa, but not only South Africa, probably to other parts of the world. And I'm going to close off by saying that we are now living in a new geological epoch, the Anthropocene. So I'm actually a Holocenian. I was born a Holocenian, but I'm now in the Anthropocene, and I gave a TED talk, to this end. We should all be proud Anthropocenians. So where did it all begin? I had a very unusual background, a very unusual childhood. My father was a Zulu-speaking white South African, and that was a very a curious artifact of history. My grandfather, his father, was left destitute after the Anglo-Boer War, and he found himself as what was known in South African as a bywoner, a squatter, tenant farmer, what you might call a kulak farmer in a place called Swartruggens, and completely impecuniary. And my grandmother was just a remarkable woman. She was a descendant of German extract, of German royalty, in fact. But she was a very, very headstrong woman, and she was pregnant in the advanced stage of pregnancy. And in those days, in this house that they were living on, they had an outhouse. There was no internal toilet. There was an outhouse, and she thought that she was feeling the effects of some ungelegde vruchten. What is ungelegde vruchten in English? Some peaches that she'd been canning the day before, and of course, unbeknownst to her, she was giving birth to my father. So my father was born in the outhouse under these terribly, terribly sordid conditions, and my grandfather was horrified. He was utterly horrified that his son, that carried the same name as him, that his son should be born in an outhouse in abject poverty. So he decided to do something about it. So he migrated down to find the only job that he could find in those days, was as a clerk of the court in a place called Hlabisa, Zululand. And Hlabisa is as far removed from bureaucratic control by the British Empire as you can imagine. So my father grew up immersed in the Zulu culture as a small boy, learned to speak Zulu mother tongue, and was not very well educated. He was homeschooled, and in fact, he didn't pass what we would call matric. He only had a standard 8 education. I don't know what it would be equivalent to in other countries, but it was a sort of a high school diploma that you couldn't go to university with it. So my father was not an educated man at all. And he went on to learn some skills. And one of the skills that he had was, besides speaking fluent Zulu, was he knew how to shoot. He was, in fact, the equivalent of what I could describe as Wild Bill Hickok and Annie Oakley in the American Wild West. He had the ability to shoot very accurately at very long distance without aiming. He didn't have to close his one eye and look down the barrel of a gun. He would just know instinctively with the direction that his firearm was pointing, and therefore he had the ability to make a clean kill at great distance, on an animal. So he was a hunter, and I therefore grew up as a small boy with my father hunting on the Kalahari. And if anyone knows anything about the Kalahari, it's a great internal depression in southern Africa. It's an old ancient inland lake, and it used to be the headwaters of some of the rivers that would flow out of this particular lake. But today it's a great big desiccated landscape, and it's a part of a huge desert, and water sometimes flows through there. So as a small boy, I found myself in this desert landscape in the Kalahari, sitting around the campfire under these massive, massive heavens, the blue skies that were rent asunder by the magnificent Milky Way. The Milky Way was just absolutely exquisite, and I would sit there around the campfire with my face warmed by the fire and my back to the cold outer wind. And in the distance, you'd hear the hyenas laughing, their insane laughter, and you'd hear the lions roaring. And I had this incredible sense of comfort. But looking up at the stars, I felt a sense of utter insignificance, in the context of the universe. And of course, I had the privilege at that time of seeing the last of the great mass migrations of wildebeest and springbuck and zebra. These animals would migrate vast distances. In fact, also elephant. There were also elephant among them. They would migrate vast distances. So I was the last generation to see that. And in fact, within 3 years of this experience, mine, Botswana became a sovereign, independent state, and it cut a trade deal with the European Union, what was then called the EEC, the European Economic Community. And a part of that deal was they were going to export beef to Europe, and the only way they could do that, they had to get a license for foot and mouth disease, so they built fences. And they built fences across these ancient migration routes. And the first year of building the fences literally was the last time that there was a mass migration. So subsequently, I had the sad privilege of taking my son back there when he was a small boy to go and look at these to see what we could still find of the mass migrations. And all we could find was a dead donkey on the side of the road being eaten by a vulture. There was no more mass migrations. And in that process of seeing this, I learned of my father. My father's, being a Zulu, had a traditional name, and his traditional name was called Mhlanga. And Mhlanga refers to the reeds on the side of a river, the Phragmites reeds that grow on the side of rivers, and on top of the dancing leaves of these reeds, when the wind would blow, you would suddenly get a seed pod that would pop up. And that seed would pop up above the dancing reeds, and that's what the name Umhlanga means. It refers to a person that is part of a greater whole, but stands above, but part of the greater whole. And I was just taken by that. And as a small boy, observing these wildebeest and zebra and springbuck, and sitting under this enormous night sky, looking at the in those days, there weren't satellites up there yet. Subsequently, I used to look at satellites every night. But in those days, there weren't satellites, and there were lots of shooting stars. And I felt utterly insignificant, but not irrelevant. And so I learned from my father's name the difference between significance and relevance. So as a young child, I grappled with the philosophical difference between significance and relevance. And I came to the conclusion that I am as relevant as any one of those wildebeest or springbuck. I am relevant as any one of those millions of stars in the sky. But I'm not. I'm not insignificant. I'm sorry. I'm not irrelevant. My relevance is derived from being part of a greater whole. And so that's always been my founding philosophy. My relevance is derived from being part of a greater whole. And that observation, and I was gifted as an early child. I was gifted with certain things, and one of them was I have a photographic memory, and the other thing was I was gifted with an insatiable curiosity. And if you know about the words of Rudyard Kipling, he wrote some wonderful stories about the great grey, green, greasy Limpopo, all set about with fever trees, where the elephant's child got its trunk through this insatiable curiosity. And I was that elephant's child. I had that insatiable curiosity. And I realized that, or observed, I learned how to observe. And with my photographic memory, I stored all these observations away. And I hope that one day they might be useful. And I observed that water, in fact, does flow through deserts. Deserts are not sterile environments. They, in fact, have got very dynamic ecosystems. And lots of things are happening there. So we used to camp on a place near the village of Gweta in the Great Makgadikgadi Depression, and that's on a river, the Boteti River. The Boteti River flows past there, and on occasion, maybe once every 50 years, maybe once even 100 years, the water overflows from the Okavango Delta and flows through the desert landscape. So it's an episodic flow of water, and there's lots of things that happen from that. So I started observing that, for example, sodicity is linked to aridity. And sodicity, a sodic environment, is common. In fact, unfortunately, I just removed my background in trying to be smart here, because I had a background of this Makgadikgadi area in our good old Land Rover, just showing you what a sodic environment is. A sodic environment is environment that is overloaded, overladen with sodium salt, basically sodium chloride salt. So it's a saline environment. And I observed at the same time because we used to go and draw our water at this village of Gueta, and there was a well that had been dug into the ground, and we used to lower ourselves down into this well on a block and tackle, and we'd go and draw water from this well. So I observed that even in the driest of environments, there's water underground, and more importantly, I observed that water is a social thing because there was a vibrant village and a vibrant culture that had grown up around that particular well. In that particular extremely remote part, of a desert where, I mean, very few people would ever venture there because they would mostly would think it's just a sterile environment. But then I also observed that tectonics are a factor. The movement of geological plates, the Okavango Delta, where I cut my teeth, is in fact a tectonic place, a tectonic location. It's the end of it's the southernmost reach of the Great Rift Valley of Africa. So as Africa is rifting apart, as Africa is tearing itself apart, the southernmost tip of that Rift Valley is the Okavango Delta. And in fact, the extreme southern tip of it lies buried under the sands of the Namib Desert, south of the Okavango Delta. It's a fascinating place because they're now finding water there, but they've got to drill down to about between 400 and 600 meters to find water trapped in this tectonic feature that's buried by this desert sand. So in all of these observations, got me to think about a lot of things. So one of the observations was that the tectonics have captured rivers, and there's a very interesting thing in the Okavango. There's a thing called the Cylinder Spillway, which links the Okavango to the Zambezi River. So you've got two great big river basins that are hydraulically linked periodically. So they flow only in an episodic way. In fact, they flow in two directions. So the river that can flow, depending on flood conditions, either one way or the other. Quite a curious thing because most people believe that water flows downhill. And in fact, in this case, downhill, because it's so flat, downhill can be this way or that way, depending on the flood conditions. So I learned of the Cylinder Spillway, and later on I came to learn that similar things exist. For example, in the Mekong, the Mekong River, you get the similar type of conditions. And then I later on learned about a thing called the Chobe Linyati. That's also this is very, very rich environment in terms of wildlife. So as a young child, I learned how to walk through the bush for long distances because I have to go and fetch my father's Land Rover. I would go walking with him, when he was hunting, and then I'd have to go back and find the Land Rover wherever the Land Rover was and bring it back. If say for example we dropped a buffalo, we'd have to go walk for 1 or 2 days to go and get the buffalo, and then my job was to walk back through the elephant and through the buffalo to go and find the Land Rover and then bring the Land Rover back to where this animal had been shot. And so that's how I learned it. And in the process, I learned that everything is connected, but nothing is as it seems. And I think that's an important message. Everything is connected, but nothing is as it seems. And what we see today is not permanent. We like to think of everything around us as tangible and permanent, but actually it's all transient. And I think this. So I was just a young pimply-faced teenager at that point in time, and I learned these things. So my first big lesson that I learned, the first very, very big lesson, is that everything is interconnected, but the study of that whole is fragmented into disciplines. And woe betide the person that decides to reach out across disciplinary boundaries. Woe betide that person. It is a career limiting move. And that was a big lesson that I learned. So the physical sciences I subsequently learned. As I said, I had the privilege of visiting Cambridge University and sitting under that famous apple tree. Physical sciences are based on reductionism and empirical measurement of two variables, an independent and a dependent variable. And if you can reduce a complex reality to two things, temperature and pressure, or distance and time, or whatever, the two variables. One comes first, the independent variable. You change that, and you get something happening on somewhere else, and that's the dependent variable. So my life has been a quest of trying to find what these variables are, and trying to find which of them is an independent one and which is dependent. But then I also learned later on, because of the societies that I was observing growing up around these water sources, that the social sciences are based on an epistemology that defines the universe being studied, but it also selects the methodologies needed. So it's not a neutral thing. The methodologies used in the social sciences are not by any stretch of imagination neutral. When you work within the framework of a paradigm, the paradigm tells you how to define the problem and how to select the solution for that problem. So it's not a neutral thing at all. Both are relevant, but each is exclusive of the other. And very few tend to reach across from one to the other. And my early quest was, I'm going to have my first aha moment. I fell in love with the study of epistemology, which is probably boring for most people. But epistemology is the science of determining truth, the science of truth determination, or the science of knowledge, how knowledge is constructed. Is the knowledge of the traditional bushman, the San, that has lived in the desert for tens of thousands of years, is that relevant to in a modern world where Newtonian physics defines, for example, how the Doppler effect works, how your modern mobile device in your that you use every day, how that works. And that was the aha moment. I fell in love with epistemology. And my one critique today when I'm working with PhD graduate students is that very few of them understand epistemology. And one of the greatest stumbling blocks I find with wannabe PhDs is they can't separate an independent from a dependent variable. I've got to spoon feed them and help them to understand, to grasp this concept. What is independent, what is dependent. So Newtonian. I just fell in love with this whole thing called epistemology, and I was privileged to study it all the way up to a graduate level. It was one of the most fruitful times of my academic endeavors. So then my second big lesson. This was also another aha moment, and there I learned that physics and chemistry drives everything, but can't explain everything. So it drives everything, and it's very simple. Physics is generally about gravity, and we need to look no further than what's happening in Moscow now to realize that gravity can be lethal. And gravity is powerful. It's what keeps us all on the firmly rooted to the chairs we're sitting in. And gravity is generally your friend until it's not your friend. So Newtonian reductionism is the golden standard, but René Descartesian logic explains why. And here I go back to my PhD time in London. I had the privilege of spending a period of my life in London, working under a guy called Tony Allen, Professor Tony Allen. He was my mentor and my guru, and I loved every moment of my life that I spent in his presence. And one of the people that I met when I was staying in a graduate like a hall for foreign students at the place called the William Goodenough Trust at Mecklenburgh Square in London. And there I met a young Canadian woman who was a philosopher. And I'd never met a real life philosopher. And I'd always felt sort of philosophical leanings in my life, but I'd never met a real genuine, I can go and touch you and say, you are a philosopher. I'd never met such a person in my life. And yet I was studying a PhD, which is a Doctor of Philosophy. And I thought I'd better learn a little bit about philosophy if I'm going to carry a title that has this in the name. And she said, I need to understand René Descartes. So I dutifully went along and I started learning about René Descartes. And one of his famous sayings, nous rendons comme maître et possesseur de la nature. By so doing, by observing, we can become masters and owners of nature. And she said to me, that's what you need to understand. And that's how I learned a lot about being master and owner of nature. And I was very taken by his powerful descriptions. He spoke about knowing the force and the actions of fire, water, air, the stars and heavens, all of the things that I'd intuitively grown up with, and all the other bodies that surround us, and thus render ourselves, as it were, masters and possessors or owners of nature. And that in fact flew in my face, because I felt not to be a master and owner of nature. I felt rather my childhood experience was as an observer or a participant in nature, not a master and owner of nature. So this master ownership thing was a very, very important part of my growing up in apartheid South Africa. This whole issue of racial tensions and master subservient relationships was very much part of the lived experience there. So this honestly became one of the most exciting moments in my life. And I learned it while doing my PhD in London, where I met this Canadian philosophy student. She was studying at King's College, and she was actually asked her what her PhD work was about, and she was doing it for some other police department in Canada, and she was studying the concept of we serve and protect. What were the philosophical roots of we serve and protect? And yeah, I found that all quite bizarre and quite strange, but nonetheless very, very interesting. So there, through her, I learned about Descartes' discourse of methods. And I then discovered the links with Francis Bacon and how these competed and combined to shape what became known as the scientific revolution that Isaac Newton was part of. And I then subsequently met another person, also a woman, an American woman from upstate New York City. She also did a PhD, and she was part of a team working for Shell, the Shell oil company. And she was developing with another very, very famous Frenchman, a guy called Pierre Vac. She was developing the methodology of scenario planning, and Shell became world famous for its scenario planning. So I got sort of sucked into the scenario planning thing on the sideline. So in London, I discovered the same joy that I experienced under the night sky of the Kalahari when I was contemplating the fact that I'm irrelevant but not insignificant. The discourse of methods details Descartes' quest for absolute certainty by doubting all prior beliefs and establishing the existence of the self, famously summarized by his philosophical assertion, I think, therefore I am. And the one thing I've always been is a thinker. I've probably overthought things. My mother used to always tell me, just lighten up a bit, stop thinking so much, So just chill out and just enjoy the moment, That is my good old mother always telling me I should think less and be happy. Think and be happy. Think less and be happy, because a thinking person is very often not necessarily bubbling with effervescent enthusiasm. From this moment, I adopted the 4 rules of method. And later in my life, I was invited to become a Rotarian, and I discovered that this is remarkably similar to what Rotarians believe, the 4-way test. So the 4-way test that I early adopted, I was an early adopter of this 4-way test from René Descartes, and that is accept only as the self-evident. Never accept anything as true unless it is known clearly and distinctly to be true. Avoid precipitate conclusions and preconceptions, accepting only what presents itself to the mind so clearly that it is beyond all doubt. That's rule number 1. And the second one was break down difficulties through analysis. Divide each problem or difficulty into as many constituent parts as possible and resolve each of them more easily. The third one was think in an orderly fashion. I've always been a very orderly and logical thinker. Conduct thoughts in a systematic progression, beginning with the simplest and most easily understood objects, but gradually ascending step by step to the most complex knowledge. And that has really pretty much been a summary of my life. And then the fourth one was be thorough and review. Make complete enumerations and general reviews to ensure nothing is left out and no logical steps are missed. And those four things are, pretty much the framework by which I live my professional life. And from that moment onwards, I used to live it before that, but it just suddenly took on a more tangible, a coherent whole. Uh, Chemistry is logical because it's simply about anions and cations, and anions and cations that react, opposites attract, and likes repel. And that's, if you understand that simple thing there, and you apply that to chemistry, then you can learn a lot about how you can actually make predictions of how things are going to react. But this left me excited, but also frustrated. I've always had this tension in me, this tension between really being incredibly inquisitive and being excited by in my inquisitiveness, but also being frustrated that it doesn't explain everything that I want to try and understand. So I wanted to connect things. I needed to understand how holism matters, but I was hampered by institutional career pathing and dogma. And here I start to use the word dogma because I subsequently came across that in my life because I was the product of a country at war with itself. I was a young white male, and therefore I was conscripted into the army. And I served for 12 years in the army at the front line of combat operations. And I was later migrated across to the National Intelligence Service, where I played a significant role in establishing the democracy that we now live under, even if it is in distress. So I learned there that dogma can be your undoing, because dogma is almost like a prison sentence, or it's almost like a pair of handcuffs that you can't break out of when you are placed under arrest by a policeman for some or other reason. So I also saw dogma as the enemy to be vanquished, but I never knew how. How do I vanquish this thing called dogma? I instinctively knew that to take dogma head on would be fatal. If you were driving down a road in the United States of America, in Arkansas, and a blue light suddenly pops up behind you and asks you to pull over, don't resist it, because to resist that, it's fatal. They have the power of the state in their hand, and you are the subservient being, and to resist is futile. So I learned this, at that point in my life. Not that I was ever patted down by a county mountie, but I did have a few. I was pulled over once or twice. Once driving up to Baltimore, I was pulled over by a county mountie, and I was fully compliant. And he went to his computer on his dashboard, and he confirmed exactly when I'd entered the country and what visa I had, and I was quite amazed at that point in time in the 1980s, how he knew everything about my life just by looking at a screen in the front of his cruiser. So I learned a skill of adaptation and hiding my true inner feelings. I never put them. I never wore my emotions on my sleeve. I would always hide them away. I'd hide away my inquisitiveness, and I would hide away, and I would just adapt to the reality. But I was always felt uncomfortable within this dogmatic environment. In the context of South Africa, this whole thing about, if we've got a strong army, then we will prevail. And I knew as a frontline combat soldier that the strength of our army had meant diddly squat when you're facing tens of thousands of angry people that are now burning tires, and they want liberation. The strength of your army is actually a disadvantage at that point in time. And that's what took me into this National Intelligence Service world of mine, with working with Dr. Neil Barnard, and creating the pathway to the negotiated transition that we had. Okay, so that leads me to the third big lesson in life, in my life. I'm not prescriptive, but in my life, the third big lesson was that geology has a fingerprint. And that fingerprint is an exciting thing to learn about. And it's one of the many fingerprints is known as the KT boundary. And that's the boundary between the Cretaceous and the Tertiary period of geological evolutionary timescale. It's now formally called the KPG boundary, because fashions come and go, and it's still defines the same thing. But it was discovered by a team led by Nobel Prize-winning physicist Louis Alvarez and his son, the geologist Walter Alvarez. So the Alvarez father and son combination, along with chemist Frank Asara and Helen Vaughan Michel. And this is an interesting thing in its own right, because where it happened was whilst these people were studying a distinct layer of marine limestone in the Scalia Rosa formation near Gubbio in Italy. And Alvarez discovered a mysterious thin band of red clay that cleanly separated the Cretaceous period from the Tertiary period. So there was a thin line, literally etched into the rock, a thin clay-like line, and he discovered across that barrier, that boundary, what was known as the fossil shift. He noticed that immediately below the clay line, the rock was filled with a massive variety of foraminifera, which is tiny marine fossils. But above the clay line, the rock contained none of these. So something has happened that was associated with the presence of that line, and that created a massive and abrupt mass extinction. And so the third thing that he discovered there was the iridium anomaly, because in order to determine how long it took for the clay layer to form, Walter asked his father, Louis, to measure its composition. And using highly precise nuclear chemistry, the team found that the clay contained up to 160 times more of the rare metal iridium than the surrounding rock. And the significance of iridium is that it's so rare, it's associated with meteor impacts. It's not found on Earth in any quantity. So here you've got a layer embedded in a rock that's got 160 times, two orders of magnitude bigger than background. So this was later confirmed when people were working in the Yucatan Peninsula in Central America the southern parts of the United States of America, in the Mexico area, the Chicxulub impact site that's found largely in the Gulf of Mexico. The Gulf of Mexico is formed in part by the Chicxulub impact crater. And when they found the Chicxulub impact crater, this confirmed the theory of this mass extinction. So at this point in time, I was truly blown away. And I must tell you a story about one part of my professional life. I was working a lot on transboundary rivers, and I found myself invited to an institution in Central America. And I was flying from Atlanta, Georgia, down to Central America, Costa Rica, and there was a lovely young lady sitting next to me, and she was fluttering her eyelashes, and she had a guy sitting next to her on the other side of her, and he looked like a what I would describe as a jock, one of these athletic gridiron jocks, but she was just a gorgeous creature. And she started talking to me, and I mean, who am I to resist being spoken to by a person fluttering her eyelashes and as gorgeous as she was? So we started talking, and I said, look out the window there, because as we were flying over part of the Yucatan, you could see, as far as the eye could see, a string of volcanoes. And I said, so look at those. There's a volcano there, and then straight line, there's another volcano, and there's another one there. This is a volcanically active area. This is actually the San Andreas Fault we're flying over here. And isn't this just amazing? And we had this intense conversation, and this jock-like male that was with her suddenly got all aggressive, and he clenched his hand into a fist and pointed a finger at me, and he said, "I know what you are, okay? You are a goddamn creationist." so, so I said, "Oh, okay, no, okay." So we calmed down, and I said, "No, I believe in dinosaur mass extinctions, blah blah." And he's actually the creationist. I'm the one that's challenging his thinking, because I'm a scientist that's now putting evidence in the way of his simple view of the world. So anyhow, that was just a little story on the side. So at that point in time, I was working at the Council for Scientific and Industrial Research, the CSIR in South Africa. The war had come and gone, and I was now in my post-war environment, and I was working as a scientist at the CSIR. And there was an opportunity that came up. I was part of the World Summit of Sustainable Development, that was hosted in South Africa. And there was South Africa is a mining-based economy, and there was a thing created called the Mining, Minerals and Sustainable Development Team. And their job was to show the world how wonderful mining was and how healthy this was for the environment, and how progressive South Africa was in terms of mining. So they made me part of this Mining, Minerals and Sustainable Development Team, the MMSD team. And there I applied my mind. And we were studying at that point in time the impact of mining, which is, of course, is massive. And because we just come out of this armed struggle, and because the USSR had just imploded, we studied a lot of things in the former USSR, particularly uranium and lignite mining. And we found, to our very great surprise, that in all cases, the externalization of costs was justified for national security reasons. And we then developed a model, an economic model, that I had the privilege of drawing all the squiggles on a graph. For that, I like doing these horrendograms. I like drawing because I'm a very simple-minded person, and the only way I can understand complex realities is to draw a few lines on a page to understand how things are connected together. So I drew this sort of set of graphs to show that this is what happens to the value of the extracted minerals over time, and this is the way the curve will go, and this is what happens to your environmental liability, it goes this way, and this is what happens to the externalized social cost, blah blah blah. And we developed this model, and eventually we published this thing as an externalization of cost model, and it showed shock and horror the following: A, mining is needed for economic and social development, but B, existing business models all externalize the environmental cost, taking it off balance sheet. So mining in and of itself is not a sustainable enterprise. Now, this flies in the face of what they were trying to achieve. They were trying to show the world just how wonderful they were and how progressive they were. And here, Turton was saying, no, actually, this is, you can justify it by various means, but you can't justify it in terms of sustainability. And that got me to thinking about how do we make mining sustainable. And that I went down a rabbit hole at that point in my life, and it was very, very interesting where that rabbit hole took me, because I was seriously involved in developing the thinking around sustainable mining, because everything that we have, the computers we're looking at today, the microchips, the semiconductors that enable us to communicate across the 12 different time zones, as we are doing right now, all of that comes from mining. So I'm not anti-mining at all. I'm just sort of inquisitive about how we can lessen the impact of mining and how we can mine more sensibly. Going back to my Russell Einstein experience, just because we can split the atom doesn't mean to say we should, and just because we can dig a hole 2 kilometers into the earth, can't we maybe do that a little bit more smartly? Can't we do that in a way that leaves slightly less of an impact? Can't we align that with long-term future interests of local villages and stuff like that may or may not be negatively impacted by activities? So I learned then that if full cost recovery was to be attempted, most mining operations would not be bankable, and this discovery was not popular at all. And I then launched, because I was observing in South Africa that for every ton of gold that was pulled out of the ground, between 10 and 100 tons of uranium was pulled out of the ground. And uranium until 1945 had no commercial value, so it was discarded as waste. And while I was in America, I learned of a really interesting project that just got my inquisitive mind going. It was called the St. Louis Baby Tooth Survey. And the St. Louis Baby Tooth Survey is the longest running longitudinal human health impact study in recorded modern history. And what they did, because America was detonating these nuclear devices in the 1940s, as they were testing for the development of the Manhattan Project, there was a dentist in St. Louis, Missouri, who said, but what is the impact of radionuclide fallout? What is the impact on children? And he came up with this very, very clever concept of harvesting the milk teeth from young children, getting the tooth fairy so to speak, to have a place to send those teeth to. And they sent them to the School of Dentistry at the University of Missouri. And that from that, they could now determine from a large sample size the impact of radiation on calcium formation in the tooth. And that's just an amazing thing, because they've now got that data over 8 decades or so, maybe even longer. They've got that longitudinal data that can tell them exactly what has happened to those people over time. And they can correlate that back now to radionuclide contamination in the calcium of the bones. And that was a big thing. So I decided to launch. Turton has never been one to have delusions of grandeur, but he's always never been afraid of being inquisitive. And I thought that if they can do it in St. Louis, then why can't we do it in South Africa? And I proposed a thing called the Tooth Fairy Project. And I wanted to harvest milk teeth to determine whether humans were being impacted by the presence of uranium in the many mine dumps around the Johannesburg Witwatersrand mining area. And this concept actually was introduced to me by Pugwash, believe it or not. And nonetheless, my Tooth Fairy Project was announced in the media, and it became a career-limiting move for me, because from that moment onwards, my career took a downhill trajectory, because I was now bumping head on with the mining people, and they didn't want anything to be done on uranium impact. They wanted nothing. If you talk about uranium, they used to refer to mineral X. Mineral X, you can't even use the word. The word itself is so sensitive. So anyhow, we'll get back to that now, because my fourth big lesson in life, we are now living through a change in geological time that is not yet called an epoch, but might well become one. And now, getting back to my work at the CSIR on mining, 5 things rapidly became evident to me. Uranium had no commercial value before 1945, so it was merely discarded as waste. The Witwatersrand gold mining basin, of which Johannesburg is at the center, is the most uranium-contaminated urban landscape in Africa, possibly in the world. And now, as a scientist with access to all of this equipment, I could go and measure stuff, and we could do all kinds of incredible things. We found that human migration now placed around 1 million people in direct contact with uranium-contaminated tailings in Johannesburg. And if anyone has ever grown up in Johannesburg, anyone in the audience, if they've had any sort of contact with Johannesburg, when I was a child, the flagstones on the side of the streets in Johannesburg, the paving was laid on yellow golden mine tailing sand. So the uranium contaminated tailings is everywhere in Johannesburg. Everywhere. It was in the void under the raised floors, because some of the better quality houses in Johannesburg all had raised wooden floors, and because of termites and stuff that would eat the timber, they would put in mine tailings in that void, and those mine tailings would keep the insects away. And no one ever asked, why are the insects dying? The insects are dying because of radon gas that's being emitted as uranium is decaying, and radon gas is heavier than air, and it's now well studied all over the world, the human health risk of radon. So that's the simple reality of Johannesburg. So getting back to my sort of earlier statement about good science should have a human conscience. It was for me unconscionable that so many people could be exposed to this. And if as a scientist I knew about this and failed to act, then I was acting. I was now a co-conspirator. I was a co-conspirator to something that was almost like a crime against humanity, if you like, and I could not be that. I could not be part of that. So I was obliged. The activist in me, even though I don't like that word, the activist in me obliged me to speak out. And then we started measuring, with various equipment that we had at the CSIR. And we found that bricks they used for building houses are made of clay that it's very often associated with the close presence of mine tailings, and therefore bricks have got a high level of radionuclide contamination. So now the question is, almost every house in Johannesburg, certainly the older houses, have all been built out of bricks. Now, do we go make an announcement that that people are living in direct contact with uranium? What is the implication of this? Do you cause a mass panic? Is this how do we deal with this from a professional perspective, a moral, ethical perspective? So. Uh, as you said earlier on, I was the spokesperson at that point in time on water for the CSIR. So the media would always come to me. I was the first point of contact, anything water related. So I had the media at my disposal. I could make a statement and they would listen to me, but I didn't make a statement on this uranium contamination because of the fear of what the consequences would be. And then we started to learn now that uranium plumes are now measurable in river sediments at 1 or 2 orders of magnitude higher than the iridium found in the KT boundary. So I spoke earlier on about the KT boundary. So there, iridium was the signature, and here we can now say in our rivers in South Africa that we've got this radionuclide contamination of at least 1 to 2 orders of magnitude above background of uranium and derivatives. So not only uranium, also of other heavy metals, nickel and lead and all these. There's a whole host of things. Okay, cadmium and stuff like that. So political leadership and big corporations don't want to know about this problem. So to work on it professionally is literally a career-limiting move. And the Tooth Fairy project had consequences, and my consequence was I was eventually suspended from my role at the CSIR, and it was that suspension that propelled me into a fairly high level of public visibility because I had a presence in the media, and suddenly the media got wind of this and what's happening, why am I being suspended? And that turned into an absolute fiasco, an utter fiasco. But nonetheless, I won't go down that rabbit hole. So I was now confronted by an ethical dilemma. Do I shut up and protect myself, or do I act according to the Russell Einstein manifesto that I believe in as a pugwashat? And I chose the latter. I chose the latter, and I chose it unashamedly, and I have absolutely no regrets about choosing the latter. And I then found myself at a very interesting moment in my career, because I was invited suddenly out of the blue. I received an invitation to attend the Royal Swedish Academy of Sciences in Stockholm. And the pretext of this invitation was that Marlon Falkenmark, a professor that I had a very close association with, a woman who was involved directly in the first World Summit on Sustainable Development. She was the only person that had the presence of mind to ask a simple question: is there a finite limit to the number of people that a given unit of water can sustain? And she did a PhD work on trying to quantify, trying to get that number of what later became known as the hydraulic density of population. And she was being given a Lifetime Achievement Award by the Royal Swedish Academy of Sciences. And part of her prize was the fact that she could invite, I think, 8 or so people from anywhere in the world that had used her work and taken to the next level. And I was one of those 8. And lo and behold, I find myself there now, sitting in Stockholm, and I find myself sitting in a taxi going from my hotel to the Royal Swedish Academy of Sciences. And being an inquisitive person that I am, I always talk to the person next to me. I told you the story about this gorgeous young lady with the fluttering eyelashes, in the airplane as we were flying over the Chicxulub mass extinction event location. Well, I just got talking to the guy in the taxi next to me, and he was a French-speaking guy, and I speak a bit of rudimentary French. And I asked him what he's doing, and yeah, he's also here as part of this Falkenmark ceremony at the Royal Academy, and he's working on radionuclide plumes in the sediment of rivers. Now that immediately piqued my interest. He was a geotechnical specialist, and he told me that radionuclide plumes at 1 or 2 orders of magnitude above background levels were measurable in European rivers. Now that's surprising. They haven't been detonating nuclear devices in Europe. So what is going on in Europe? And I told him about my CSR work into mining. And I then asked Habeck if there is a date to the KT, is there a date like the KT boundary, which is plus minus 65 million years ago, before the present? And his answer, he looked at me without batting an eyelid. He said, yes. And he said 1945. And that was the first detonation of the nuclear weapons, the development of the nuclear weapons for Hiroshima and Nagasaki. So 1945 is precise about that. They're using that now as a sedimentary layer in the rivers of Europe. Anything before 1945 doesn't have radionuclides, and anything younger than 1945 does have. And in that moment, I just knew my life had come full circle. It was literally an aha moment. It was a bingo moment. And I was part of the team then with Marlon Falkenmark and this Habeck fella and a bunch of other people. And we published the paper in 2014. The paper is called The Unfolding Water Drama in the Anthropocene Towards a Resilience-Based Perspective on Water for Global Sustainability in Ecohydrology. And thereby we became one of the early adopters. I almost thought, I labored under the illusion that we were the first people to publish about water in the Anthropocene. But I did a good old Google search, and I found out that we are not the first. The first, in fact, was Paul Crutzen, the guy that developed the term Anthropocene. He published in 2002. And his work was about aquatic ecosystem behavior before the 2000 periods. And scientists began linking human alterations of the global hydrological cycle to large-scale irreversible changes. So Crutzen, the guy that invented the concept of the Anthropocene, was the first guy to actually write about it. But we were in the second group of people that actually wrote about water in the Anthropocene, and I'm very proud of that little humble achievement. And I was then asked to visit Spain, and I always loved Spain. I've been there a few times. And I was asked to present my work at an institution known as ASLO, the Association for the Sciences of Limnology and Oceanography. Now I'm not an oceanographer, but I've rubbed shoulders with a lot of limnologists. I don't know if I'm not a limnologist, but I know what they do. So I was quite humbled when I was invited to this event in Granada, Spain. And I gave a plenary talk there on transdisciplinarity, in which I referenced the uranium plumes in South African rivers. And if you're going to write anything up about it, I've given you the link there to the talk that I gave in Granada that explains this whole thing. So let's start tying this whole thing up now. What were the 4 lessons that I've learned in my particular life? The first lesson that I've learned is that everything is interconnected, but nothing can be understood holistically because of Newtonian reductionism and dogma. So Newtonian physics is actually a limiting factor. It's a limiting factor. And those people who believe so doggedly that this is it, this is the supreme thing, this is the ultimate, they are wrong. They are wrong. They are wrong. And I stuck my neck out when I was in the Royal Swedish Academy of Sciences, surrounded by incredibly well-educated people, and I made a statement to this effect. And in fact, the statement that I made to them, I said to them, please, I'm sitting in this esteemed audience today, and I'm going to make a statement now. I want you to, by show of hands, tell me if you disagree with me or not, please. And the statement that I made is that water is a flux that flows in time and space, but we manage it as a stock, a single-use item. And not one person put their hand up to refute what I was saying. And I said to them that I take that as democratic affirmation for my statement. And from that moment, I started talking to anyone that is interested in listening to me about water is a flux, but we manage it as a stock. And therein lies the secret of our future, because the volume of water on planet Earth today is the same as it was when the dinosaurs roamed freely. And in fact, when you clean your teeth this morning, at least one molecule of that water that went into your mouth went through a dinosaur's kidney when the KT boundary happened. And in fact, in all likelihood, another molecule went through someone else's kidney maybe a week or so ago. Okay? So that's the reality of life. So that's the good news, is that we're actually not going to run out of water, because technology will help us through it. But the bad news is that water quality is getting to be nasty. So that's the first lesson. The second lesson that I've learned is that physics and chemistry drives everything, but can't explain everything. The third one, geology has a fingerprint. Understand that fingerprint, and in fact, water also has a fingerprint. You can fingerprint water. I was involved in a number of projects where you could fingerprint water, literally, you can fingerprint it with a high level of precision, and you can know exactly where it comes from. And that enables the salmon to swim up the rivers to go and spawn in the place that they were born, because they know the fingerprint of the water where they come from. They've got sensors they know what anions and cations and what sodiums and calciums and bicarbonates and whatever are in the water, and they know exactly where they must go back to because of the fingerprinting. And the fourth lesson that I learned is that we are now living in a new geological era, the Anthropocene, but we are still applying Holocenian dogma. So Holocene, we haven't broken free from this reductionist physics, the concept of reductionism. And in fact, if anything, that dogma is now being reinforced. We get the likes of Donald Trump and these sort of attempts to stifle science, to defund science, to take funding away from these major institutions, because they are not politically expedient. So we're going backwards, not forwards. So where's the proof of what I'm saying now? We need to look no further than aquatic ecosystems, because they contain a lot of the evidence that we need. The aquatic ecosystems are an interface between land and water, the big biblical divide noted in Genesis. And literally the creation of a story is about first the water and then the land and then and then all the living things. And it's also the interface between surface and atmosphere. It's the interface between salt water and fresh water. And each of these have got a fundamentally different physics and chemical signature. And that's the interface with global level forces that drive ocean currents and the hydrological cycle. The ocean currents of the world are driven to a large extent by the flows of one river out of South America. And that river alters the salinity level of the southern Atlantic Ocean. And as a result of that, you get what's known as thermohaline circulation that becomes the Gulf Stream that causes New York not to freeze over as Moscow does. And all of these good things happen because of thermohaline circulation. So what are these examples of hotspots? I now live in Australia and I'm learning about Australia. The Murray-Darling Basin is an incredible hotspot, incredible. It's a hotbed of intense political positioning and bargaining. It's an arid but vast landscape with very sparse human population. And the alteration of the flood pulse by the Snowy Mountain hydroelectric scheme is the immediate cause of all of the problems. This has altered the flows of water through arid areas where high evapotranspiration occurs, and one of the unintended but predictable consequences is irreversible salinization. Irreversible salinization. Remember, I told you earlier about sodicity and why sodic environments are associated with aridity. Well, here you've got a very arid environment, and you are depositing salts on the land, and that's evaporating off the land. So salinization is an inevitable and predictable outcome. Estuarine flows fundamentally altered to such an extent that a saline wedge intrusion is a reality, and people at the southern end of the river, at the distal end of the river, are now trying to fight against this saline intrusion, but it's once again, it's predictable and almost irreversible. Science is not popular because it clashes with the political realities on the ground. People want to know. They want their river, they want the irrigated agriculture, they want the jobs, but they don't want to know that science says, but you can't do it this way, because if you continue doing it this way, you're going to end up with a sodic landscape, and nothing will grow here. It will become like the Mahari Khari, the salt depression. So carry on doing what you're doing, and that's what you're going to get. They don't want to hear that. Uh, there's another thing that's come out that I've observed: new order rights. New order rights. These are rights that are accrued from people who've now been given irrigation rights subsequent to the commencement of the project. It's an irrigation project, so people have now acquired rights, and you can't just take those rights away now. So now you've got this clash of legal entities because people are defending their rights. Law and policy has lagged behind development, so it is reactive only. And sustainability is a swear word in a highly politicized debate that presents science as the villain. So that's an interesting concept. And just recently, I was invited by people associated with the Australian Foreign Ministry, and they asked me as a water specialist to come and sit in on one of the meetings that they were having, a diplomatic meeting with people from Portugal. So Portuguese people were visiting Australia. They wanted to learn about this whole saline thing and the management of rivers in highly arid areas. So they invited me to participate in this event. And this event was about the Guadiana River on the Iberian Peninsula. I don't know if you live in that sort of vicinity, but the southern part of Spain, the southern part of Portugal, the Guadiana River is a large transboundary river, and they've got a big dam that they're very proud of called the Alqueva Dam. It's the largest reservoir, or one of the largest reservoirs in Europe. The basin is shared between Spain and Portugal. They've got 80 dams in the river basin, 80 dams in the river basin. So the flood pulse is completely destroyed. The flood pulse is feeble or non-existent. And the basin storage is 8 times the mean annual runoff, 8 times the MAR. Now, the Orange River Basin and the Limpopo River basins that I'm familiar with in Southern Africa are 2.7 times MAR. So they've got storage there of almost 3 times the total mean annual runoff of the basin. But here in Spain, 8 times more they've managed to capture. The Albufeira Convention was signed in 1998, which gave Portugal rights and allocations. The area that it drains gets 550 millimeters of rainfall per annum. 550 is very, very low. It's a desert environment. It's a very arid environment. I don't know what that is in inches. But with 80% of that rainfall falls in winter, so it's a Mediterranean environment, hot, dry summers and cool, rainy winters. The Guadiana River forms part of the border between Spain and Portugal, and there's a saline wedge that goes up the estuary, 75 kilometers inland. And that thing will go as far inland as gravity will allow it to go, and they will not stop it. It is an unstoppable force. Environmental NGOs are concerned about hypersaline waters in the estuarine salt marshes, and there's groundwater depletion in the upper reaches in Spain, and it's become a major problem. The groundwater has been totally depleted. Once it's gone, it's gone. You're getting the same happening in the Levant at the moment, same thing happening in the Middle East, same thing happening in North Africa, same thing happening in the Ogallala Aquifer of the United States of America. So exactly the same thing, groundwater depletion. The demand for ecological releases will not mitigate the saline intrusion because the physics and chemistry of water dictates that if you release fresh water from a dam upstream of a saline wedge, the saline water is more dense, it sinks to the bottom. Fresh water is less dense, it flows over the top. You'll release your dam, empty your dam, the water will flow over the saline wedge, will not make the slightest difference to the average salinity of the estuary. So you'll waste your entire reserve, and that's it. Okay, so then we start wrapping up now. Another bit of proof is radionuclide contamination in the Witwatersrand mining basin. I mentioned earlier on, for every ton of gold removed, between 10 and 100 tons of uranium was removed, mostly discarded as waste. And migration has now created a situation where more than 1 million people now live on tailings disposal facilities that is uranium contaminated. Total uranium load in the Witwatersrand mining basin is 600 kilotons. 600 kilotons, quantified with the highest level of precision, is 600 kilotons across a hydraulically defined, the 4 hydraulically defined mining basins in the Witwatersrand mining area. It's concentrated in the Western Basin, where 400 kilotons exist in just 3 mine dumps: the Cook, the Doornkop, and the Millsite mine dump. just 3 mine dumps, 400 kilotons of uranium found there. Uranium and other heavy metal plumes are now measurable at orders of magnitude above background conditions, exactly like the KT boundary. Found in sediments of the rivers draining the areas, also found in wetlands typically associated with the upper reaches of the basin. You get Elian plumes. These are wind-blown plumes of fine dust, have never been measured. So the dust that blows off these mine dumps could be deposited hundreds and maybe even thousands of kilometers away. We know, for example, that the sand from the Sahara Desert gets blown across the Atlantic Ocean. So these dust plumes can be blown over vast distances. No one's ever measured because it's politically inexpedient, and the mining companies do not want it to happen. So we don't know to what extent we are depositing this alien form of uranium pollution over our food-producing areas. And the important thing is that Johannesburg is probably the most uranium-contaminated city in the world. When we did we were doing some work on the measuring the radioactivity of various building materials, and we found that the concrete that was used was very often made from waste rock that was contaminated with uranium. So you get buildings where the concrete structure itself has got a measurably high radioactive signature. And there's this moral ethical thing I spoke from earlier. Okay, I'm going to start wrapping up now. Just with the last thing, rainwater acidification. I did a lot of work into the rainwater. Sulfur dioxide and carbon dioxide both alter the pH of rainwater. It's extremely hard to measure because if you measure a drop of rain falling now and you measure the pH half an hour later, it will change because the gases in that drop of water have outgassed. And it's the presence of those CO2s and the SOxes and NOxes, the sulfur dioxides and the carbon dioxides that actually alter the pH. This interacts with the soil to either bind to bind or release microelements, and it's the low pH of rain that releases uranium from the top of your tailings dams. Anything below a pH of 5, and we measured rain with a pH of 3. So 3A is almost like battery acid. And it's that low pH of rain that falls on top of the flat tops of these mine dumps that causes a concentration of uranium. And when it goes through a desiccation cycle, a cycle of wet and dry, you start getting the uranium mobilized through each cycle, and it gets concentrated in the crust. And then when it dries up and it becomes completely desiccated in the hot, dry months of the year, then the wind blows, and then it blows that fine dust away over vast distances. So we're seeing this happening now across our agricultural land in South Africa. Okay, ocean acidification, we see this happening now all over the world. The top 10 meters of all oceans are the most biologically active. The top 2 meters is where active gas exchange occurs. And the oceans have got a larger surface area than the land mass. So oceans are terribly important for gas exchange, particularly sequestering carbon dioxide, etc. It's all happens in the top 2 meters of the ocean. And saltwater chemistry is generally alkaline in nature, so carbon is sequestered into corals and shells. So the reason why you get corals in the sea is because the pH of the chemistry is alkaline. In other words, a high pH. And acidification alters this in a fundamental way. So you can't get seashells forming, you can't get coral reefs forming. Therefore, you're not getting sequestration of carbon in a permanent way. So getting to my observations, and then we're wrapping up. At no time have we ever had access to as much information as we have today on planet Earth. At no time in our collective history has the trust in human scientific information been so low. At no time in our collective history has the need to think holistically been so high. But at no time in our collective history has our capacity to reach consensus been so low. So these are observations of mine. At the very time when we were able to harness the sum total of human knowledge as never before, we also have the lowest capacity to convert that knowledge into viable policy in our collective best interest as a species. Just because we can do something like splitting the atom or fracking the earth doesn't mean to say that we should. And the difference between can and should is wisdom. And I leave that. Wisdom is a scarce commodity. So I'm just going to summarize now by saying that there are 5 aquatic ecosystems that are now showing risks that only holism and transdisciplinarity can mitigate. And I'm going to list them here now. The first one is salinization. You get salinization taking place in all over the world. Second one is eutrophication. Look no further than the reflecting pond in Washington, D.C., where you see that green reflecting pond. That is eutrophication. Eutrophication is happening all over the world, and that's about nutrient enrichment that causes biological life to flourish, particularly blue-green algae, which is toxic. Blue-green algae are the oldest life forms on the planet. They gave us the oxygen that we breathe. The third aquatic ecosystem risk that we are dealing with now at global scale is acidification. Acidification of soils, acidification of oceans, acidification of rain. The fourth one is a very serious one, and we don't know how to deal with it, and that is endocrine disruption. If you look at the kids of today, the kids that go to school today, 80% of them have got some kind of food intolerances or some kind of ADHD disorders or some kind of concentration disorders, etc. And it's all to do with endocrine disruption. So we've thrown endocrine disruptors into the environment. It's in our water we drink. It's in the food that we eat. It's all over the show. And then the fifth one is persistent organic pollutants, POPs. These are things that exist for a long period of time in our aquatic ecosystems. So in closing, I'm going to just close off now. I've shared my journey through life with you in the hope that you might learn something from this humble journey of mine. I've shared 4 lessons that I've learned, and these lessons are as follows. Number 1, everything is interconnected, but nothing can be understood holistically because of Newtonian reductionism and dogma. Second lesson, physics and chemistry drives everything but can't explain everything. The third big lesson is that geology and water both have fingerprints. The fourth is we are living in a new geological era, the Anthropocene, but we are still applying Holocenian reductionist thinking. We need to understand the limitations of Newtonian reductionism and start to actively build a community that embraces transdisciplinarianism as an asset rather than a threat. If we get this right, we might be able to survive. And I say this, we might be able to survive the transition from the Holocene to the Anthropocene. Because you see, the last transition, the KT transition, was a mass extinction event. Let's not lose sight of the fact. The fact that the human hominids are the only living sentient beings that have only been around for a relatively short period of time. But if you look at hominid species, the longest living hominid has been around for 4 million years. And every single hominid species besides ourselves have become extinct. So we already know that hominids end up in extinction. Homo sapiens has not. So at least if we think holistically, we might have a fighting chance. I don't want to be pessimistic, but we might have a fighting chance. Above all, I've tried to demonstrate that while I, as an individual, am utterly insignificant, my relevance is derived from being part of a greater whole. You are all part of that greater whole. Holism for me has been a living journey rather than an ideological quest. And with that, I thank you for your time and attention. I hope I haven't overshot my time because I totally lose track of time when I'm talking. And I'll gladly take any questions that you might wish to throw my way. Thank you. Back to you.
Wow. Tony, that was a bit mind-blowing, a deep challenge, and just a few observations. What struck me was your point of the relevance versus significance. That struck me. What also struck me was the deep implications of your insight of the idea that water is flux, it's flow, and we treat it as stock. That struck me. What also struck me is when you said that the molecules of water that I'm drinking might have passed through the kidneys of a dinosaur. And where we live here at 1,000 meters in the Sierra Nevada, we get our water from the snow that melts. I'm kind of glad that I don't mind the fact that it went through a dinosaur's kidney, but I hope there's not uranium in it. But I think the most significant message is that we need that paradigm shift in consciousness. And that is what the Holos Earth Project is about, is to create that community. So deeply grateful. And I'm sure there are observations and questions that folks have been contemplating. So stick up your hand and we'll invite you to phrase your observation, phrase your question. One observation while we wait, our last presentation was by Dr. Glenn Martin, and he was talking for a need exactly like you described it, of a global Earth constitution.
He's on the call.
And he's here with us today. I see Nameka's hand up, and you're muted, Nameka.
Yes, thank you, Claudius. I would yield to Christopher Cook. His hand was first before mine. Permit me, please.
Okay. Thank you, Nameka. I was happy to let you go first. So I've learned, Anthony, I need to flutter my eyelashes at you when I ask you this question. And it's a question I was posed in a field today by the owner of a large land base. And he just popped up with this question. So what do you think we need to prepare for this next significant El Nino event? And I didn't quite know how to respond to the question other than say you need to reach out to those who have better knowledge than I. But given your wizardry, I believe, with the core dynamic of the soul of water, the soul of life on this planet, which is water, I wonder what you would say about that question.
Christopher, okay, a couple of things. So firstly, I've a bit of difficulty hearing exactly what you've said there. So it's about El Nino. I'm correct. Well, what specifically about El Nino? Just be very, very
well. There's
precise.
Lots of news about the El Nino at the moment,
yes,
and the pending chaos that's likely to arise. It's a hydrological issue, and it's arguably the sort of scale of event that you are interested in. But also it reflects the unique qualities of water. And I just wondered, how would you respond to such a question? How do we prepare for the El Nino?
Before I answer that question, I'm very interested in your accent. Where are you from, Chris?
I'm in the UK. I'm currently in Cornwall, but I'm from Northern England.
Okay.
And I've really reveled in your conversation. I've had a long, hot day. And your presentation was so refreshing. I feel like I've had a shower. So thank you.
Okay. So you almost had a bit of a Geordie accent there. So that's why I asked you. So not quite Geordie, but nonetheless. Okay. So yes, the thing about El Nino. El Nino is a very real phenomenon. It's not an airy-fairy thing that's been sucked out of the thumb of some smart scientist who wants to get a peer-reviewed paper so that he can get a bonus at the end of the year. It's not that at all. In fact, Southern Africa, where I grew up, is not dissimilar to Australia, where I now live. And it's found itself boxed in between three different major forces. The one major force is the El Nino Southern Oscillation. That is a planetary force because, shock and horror, I've learned that the Pacific Ocean does actually exist. And I've learned that it covers almost half of the planet. The Pacific Ocean is massive. I drove along the east coast of Australia a couple of months ago, and I was just shocked at the vastness of the Pacific. And it literally almost covers half the planet, and it's important. So what happens over there bounces around. In the case of Africa, it bounces across through the Himalayas, through the climatic system. Forget the name of the climatic system, but there's a thing called the Southern Indian Dipole. The Southern Indian Dipole bounces this thing around down into the Indian Ocean, and then of course at the opposite end of the Indian Ocean you get the Great Southern Ocean, and there's the Great Southern Ocean that now sends these huge big cold fronts up on onto the southern tips of all the continents. So in other words, we are we are being bounded by these massive forces. And I find it very, very bizarre that people would even question the relevance of this. And in fact, when I was doing my PhD in London, I was quite shocked to find that parts of southeast England are in fact fairly arid. If you apply the hydrological terminology of aridity, southeast England is actually a remarkably arid area. So we've grown up with these illusions. I said earlier on in my talk that there's this illusion of permanence, but actually everything's very transient. And so the bottom line is that these things are all interconnected, and all indications are that the El Nino is going to become an increasingly important global phenomena, and we see it playing out in different river basins now. So we see it. I mentioned this river basin in Portugal and Spain. They've feel the effect there. I mentioned the Murray-Darling. The Murray-Darling tends to have a drought once a century, what they call a millennial drought. And these droughts are really big. And I think we're heading for another one of those in the not too distant future. And all indications are that from the current data is that this current event is quite an extreme one. So I'll close off by saying that we are privileged to live in the modern world, but we're also cursed to live in the modern world. It's a privilege and a curse. And the privilege is because we can see all the data. We have all these satellites that are telling us exactly what's happening. We can see for the first time, we can have a truly global view of phenomena. And yet at the very same time, we are meeting with resistance from politically defined narratives that reject science, that reject knowledge. And I think this is an enormously dangerous time in our evolution as a species. So I hope I've answered your question, but I think I might not have answered perfectly.
I don't think there is a perfect answer, but I really appreciate your response. It also reminds me of something you spoke about, because I totally agree with you. We've got the data, but whilst ever the interpretation of the data is through models and constructs that are really dominated from a reductionist or Newtonian perspective, there's always a phase lag before we get close to anywhere near the answer. I also wonder if there's a slight contradiction in what you're saying about the need for more holistic awareness, but also transdisciplinary science. I think we need to be very clear in our language, and for me, that we're looking for words that describe a science that is the scientific, the holism of the primary knowledge and wisdom that our species holds. And I just wonder if I could add that to the layer of complexity in my comments with you.
Yeah, so where the social scientists play a role is, firstly, their logic is fundamentally different to the natural sciences. So you've got to understand that they're driven by the epistemology, where they will define what it is that they are studying, and they will use that has implications. But where they can play a role is, for example, helping hard science and the natural sciences to communicate its findings to a political audience, because ultimately it all becomes politicized. And that's where the pawpaw hits the fan. And I'll just close up by saying one other, or sharing one other observations. Mathematically, when you start integrating more than 3 variables, you don't get one definitive outcome. You start getting an envelope of probabilities. So human beings, the general Joe Soaps in the street, they haven't got a clue about that. They don't understand that stochasticity is a reality. Stochastic events are real.
Yeah.
And if we are trying to model global climatic systems, you've got more than 3 variables. You've got hundreds, maybe even thousands of variables. So the fact that we cannot predict with a high level of accuracy one precise outcome doesn't mean to say that the science is bad. It just means that that's the scientific process. Those are mathematical realities, and we need to be able to communicate that in credible ways to people. And it's the credibility, the legitimacy of the messaging. I got a lot of experience in that as the media spokesperson for water, because water is highly contested in South Africa. So I learned there a lot about how to deal with the positioning of a message and getting the message across. not always successfully, but no, it's a learning curve. But the important thing is that mathematics are one of the limiting factors, and we need to educate people, and so the social sciences can do that. But unfortunately, social sciences, they tend to use big words that often mean not too much. They're all fluffed up sort of, like, words that make it sound sexy, but they're actually not that sexy.
Thank you very much for your presentation. It was truly astonishing, and I agree. Even though I'm not a scientist, I agree with all of your conclusions and so on. Uh, for many years, I've been working to ratify the Constitution for the Federation of Earth. And the authors of that Constitution, hundreds of people, environmentalists as well as legal thinkers, during the last several decades of the 20th century, wrote this Constitution precisely to give the people of Earth, the common good of the people of Earth, the authority to actually implement the kind of things you're talking about that might just save us as a species for the future. I published in 1921 a book called The Earth Constitution Solution, Designed for a Living Planet. And in that book, I studied and reported on the major environmental thinkers. And the major thinkers almost across the board agree with your basic premises. There's a criticism of Newtonian thinking and the classical Cartesian model, and there's the need for holistic thinking, and there's the need for humanity to unite under the principles that we understand through science, which is our one, you might say it's our one common language worldwide. But several of those authors pointed out and detailed the power of capital, the power of money. You mentioned the political controversies, like here in the United States, which are very true, but they're driven in many instances by money. And for example, the big oil companies have routinely discredited science and been behind the effort to get people to doubt the process of computer generation of probabilities and so on. There's an active effort by huge concentrations of wealth worldwide to prevent human beings from uniting together. So just to make this into a question, short, at the last session of the Provisional World Parliament, we reactivated the Earth Emergency Rescue Administration, which has leaders who, the chair of which is currently lives in Spain. Her name is Alicia. And the Earth Emergency Rescue Administration is trying to bring together people and thinkers and scientists and activists into a force. Ultimately, the force wants to ratify the Earth Constitution, but the force needs to also be networking with people worldwide. And I'm wondering if we could use you as a consultant, or would you agree that we could maybe talk with you on occasion when we're formulating policies and procedures and so on?
I would welcome things like that, because I said earlier on, my relevance is derived from being part of a greater whole. So while I've still got a functioning brain, even if my memory is starting to lapse sometimes, I've still got a sharp brain, and if I can make a difference, then this is my purpose to be on Earth, and yeah, I will gratefully do anything that you ask of me. It's only a pleasure.
Wonderful. Yeah, thank you so much. Yeah.
Thank you, Glenn. Nemeka.
Yes, Claudius, thank you so much. I had to yield the floor also to the Earth Constitution. Yeah, while you froze. Anthony, I'm grateful for the insights you shared during your talk. I learned a lot. One of which is that the difference between can and should is wisdom, and of course, wisdom is a scarce resource. And something I and you share in common, I would say, is membership of Rotary International. I happen to be a Rotaractor and also a
Okay.
Paul Harris Fellow. And I can genuinely attest that the four-way test of the things we think, say, or do, which can be applied widely across every area of social endeavor, even in the family, holds true for me. It's been one of my ethical and moral compass. As a person being a member of Rotary, I ask myself in my actions, even as I speak at the moment, is it the truth, which is the four-way? That's number one. Is it fair to all concerned? That encouraged me to yield a second time to let the other speak, so it could be fair. The third being, will it be beneficial to all concerned? And will it build goodwill and better friendship? So each time I have myself, recounting this four-way test, and I have to say it's been a genuine joy walking down that path. The second I think I have in common with you is your affinity for René Descartes. I also happen to be a René Descartes, I would say, scholar. I appreciate, Cartesian philosophy, and this is my copy of René Descartes' Meditation on First Philosophy and Other Metaphysical Writings. Yeah, so I'm grateful being on the call and hearing you talk about that. Above all, I'm a little bit curious, and that goes my question as to how we talk about humanity's presence on Earth and the future for us as a species. I would like to know, dear Anthony, your view about how you think should we be speaking of humanity's future from a place of what we can and what we should do, or could we also incorporate gratitude for living on Earth and existing as a species, even if it means we eventually become extinct like dinosaurs, like
Well,
like it's an idea whose time has come?
okay, well, we're getting into normative discourse now. Normative discourse is not an area that I particularly know too much about. And normative discourse is very often about, that's the place of religion, the place of belief system. I think we must understand that there are belief systems out there, and we must be respectful of those belief systems. And I think the big challenge is how do we harness those belief systems? And I would think, in terms of that constitution, that Earth Constitution now, maybe one of the ways going forward would be to look at faith-based communities, because there are faith-based communities everywhere in the world. And those faith-based communities already have massive constituencies, and they have an interface, between the normative value of what you're trying to create, communicating a better future for humanity, and an existing grassroots constituency. So it becomes a political process, but it's not an easy process at all. But the bottom line is that people have got belief systems, and I mean, I'll give you an example. When I grew up, I mentioned that I grew up on the Kalahari, and I also grew up on the fringes of the Kalahari, in an area around a place called Panamatenga in Botswana. It's thick, dense bush. You can't see 50 meters ahead of you, and it's bush that's filled with elephant, filled with buffalo, filled with leopard, filled with lions. So it's a dangerous place, And as a 12-year-old kid, my father would think nothing of sending me to go and walk for 6 hours, to go and bring back the Land Rover to where we were. So I had to know where I had to walk to, and I had to know where I had to come back to after retrieving the Land Rover. And on my way, I would encounter things like lions, and things like elephant, and things like buffalo. Now, they're all dangerous animals. And I learned there humbleness. And the humbleness was I would always ask for permission to move through their territory. So I would never walk in silence. I would walk making a noise, And if I came to a warthole, I would know that wherever there's warthole, there's always going to be lion there. And therefore, the lion are lazy creatures, and they're not worried about eating me as a person, but they don't want me to surprise them. So I would, as I approached the warthole, I would clap my hands and I would sing a praise song to the lions, asking you, praising them, telling them that I recognize them as, this is their terrain, and asking their permission to pass through. And in all cases, they allowed me to pass through safely. I never ever once had a bad encounter with any of these things. So that's just the way that I grew up. And would I tell my grandchildren to do it? Probably not, because it might be considered reckless now. But nonetheless, that's how I grew up, So respecting other communities, and more importantly, also realizing that animals also have got conscious systems, and in fact, animals can communicate. Animals communicate. They've got social hierarchy. They've got norms and values. They communicate. If you look at the way elephants communicate, they communicate over vast distances using infrasound. And if you compare that to how whales navigate through the oceans, it's exactly the same. From my house in KwaZulu-Natal, I used to overlook a bay where female whales would come and give birth to their calves. So I've witnessed the birthing of calves, and I've witnessed the whole initial processes where the calf is now socialized into the pod. And I've seen exactly the same thing in elephant herds, exactly the same behavior. So we must stop being arrogant as human beings and think that we alone know everything. Homo sapiens is the name that we've given ourselves, wise man. Actually, we're not that wise. And the message for humanity at the moment is quite a bleak one, because if we continue on the track that we're going on right now, we are actually likely to enter a mass extinction event, a self-imposed mass extinction event, because the essence of the Anthropocene is that human beings are the only biological being that is imprinting on the geology of the earth.
Yeah.
So we are imprinting, we are changing the geological structure of the earth. And this has got profound implications, and I don't think we've even begun to ponder what that means.
Tony, there's a question, there's an observation in the chat box by Mark Pearson. And Mark, maybe you can put it, isn't an implication of your talk that we should be suspicious of any intervention in ecology and geology?
I think the simple answer there is no, not be suspicious, but we should be cautious. The precautionary principle is an important principle in any environmental management. And the precautionary principle tells us that there will all be an unintended consequence until such time as we know exactly what that unintended consequence is, then we ought to default to the side of caution. And I'll just give one example. I mean, there are many examples, but I'll just give one example now. The one example is the way that we register chemicals for use in humanity now. There's a whole complicated protocol that differs from country to country, but you've got to register a chemical, and you only register one chemical, and you have to understand what that one chemical does. But nowhere has anyone figured out what happens when 1,000 different chemicals are coming together in a cocktail in the ocean. What new molecules are being formed? We don't yet have the regulatory framework to even begin to comprehend that. And the reality of where we are today as a species is that because our population has outstripped our natural hydrological supply, we're producing a huge quantity of wastewater, sewage, and that sewage management, I would almost describe sewage management as a global crisis. Sewage management's collapsed in South Africa, completely collapsed in South Africa. But I happen to have the privilege of being part, when I was in the World Water Council, I was invited to Washington, D.C. by a very senior guy who chaired the interagency task team on water. And that was a governmental agency. And he took me on a canoe trip, a kayak trip along the Potomac River. And he was describing to me the complicated sewage management problems that they have on the Potomac River. That's going past the reflecting pond that they're drawing their water from now for this big monument. And I mean, it's a highly eutrophic system. It's a highly altered system. And this taught me that it's not just a developing world problem. It's in fact, it's also it's a global problem. And the developed world is very often a victim of its own arrogance. In fact, I said to this guy, he made a statement and he said that the American engineers were so smart that they designed wastewater works to even treat the wastewater coming off the roads. In other words, they wanted to clean the water up to such an extent that all contaminants from roads would be processed. But the problem now is that all of those systems have been overloaded and they can no longer function properly and they can no longer raise the capital to do an upgrade. So I then said to him, if you tell me now that when an alien species comes to planet Earth, and there's a spacecraft, flying saucer hovering over the state capital over there. You can see the state capital hill, and they send a message: "Take me to your leader." Are you telling me that when this happens, at the center of global power, where the spacecraft is hovering over the capital, that country is unable to manage their sewage? And he said to me, "Yes, you are correct. You are correct." So it's a global crisis. It's a global crisis. And, we're putting chemicals down the waste that have been unthought of. If you just look at since the 1960s, since birth control medication was invented, the amount of estrogen we're putting down in wastewater that's coming back into the system now. It's not being eradicated. It's being metabolized and altered. So these are really serious matters. We need to really have a serious think about the implications of this.
Thank you for that. I think we probably have stayed over the time that we were allocated, but I think Dr. Elena Komarova-Tagar, you have a question there.
Good evening. Thank you very much. And thank you very much, Anthony, for speaking also about your childhood and your family. And I felt very proud to be in South Africa and resonating with what you were talking about. And I would like to ask you, because partially its answers started to arise, because I started to think about living in Africa for more than 20 years. For example, when we think about Mahalisberg and gold mining, so what is stay behind? Considering that also in 21st century, we have got different type of technology and it becomes more and more sophisticated and more, so to speak, you leave nothing there. You extract everything for it calls efficiency in mining.
Yes.
But what is happening with that iron ore, with all that bypass products? Because suddenly it transpired through your presentation that is uranium contamination as a counterpart of gold mining. And I was thinking, and maybe we can take it further. If we are looking at Earth mining process, what is left behind there and there in different regions? Because we benefit something from taking, but we are ultimately changing that geological structure, inner structure, and suddenly we become more and more penetrable. So how Earth will be reacting in mapping that reaction?
Okay, that's a great question. I'm going to try and answer it as succinctly as I can. Okay, firstly, you need to understand that the geological ore bodies that we are mining were typically laid down in a period of geological time that were oxygen deprived. Oxygen has been a fairly recent phenomenon on the planet. So a lot of the gold-bearing ore bodies, they are heavy metals, and heavy metals you tend to find in alluvial structures. So alluvial structures are structures that have been shaped by water, typically in riverbeds or the bottom of lakes and stuff like that, where your heavy metals are concentrated. And you need to think no further than some of the movies that you watch about these gold miners up in the Klondike or up in the Yucatan, up in Alaska, where they develop a sluice. They put their aggregate across a sluicing bed, and that causes all the heavy metals to fall out. And that's exactly what happened in the lakes and in the rivers of the world before oxygen was on the planet. And that's the important thing, because associated with those ore bodies now, because it's oxygen deprived, is another iron compound. And that iron compound is a sulfur-based iron compound. And so you get sulfur and iron that combines in the absence of oxygen, and that is called pyritic ore bodies. So you find pyrite in a lot of your heavy metal bodies are pyritic, and you also find coal. Coal is also often pyritic. Remember, the coal mining belts that you mine today are the early ferns and the early vegetation that happened in a carbon-rich environment. There still wasn't atmospheric oxygen. They produced the atmospheric oxygen that we breathe today. So all of these things were laid down in a geological time period that was generally oxygen deprived. That's the first thing you need to understand. The second thing now is that when you expose that to oxygen, pyrite itself it's Fe, it's iron, and it's S. So the S gets released, and S oxidizes and becomes sulfate, SO4. So SO4 combines with water, H2O plus sulfur, and oxygen creates sulfuric acid, H2SO4. So you get an environment where you get acidification taking place under natural conditions, and it's almost like creating a fire that produces its own oxygen. Once the fire starts, you can't kill it because it produces its own oxygen. So those acidification processes are very profound. They've got profound implications for the consequences of mining. Now, okay, so that's the one thing. Now, the next thing is, I would say, is that just because we can put a man in space and bring him back safely, and we've done that in many, many times now, I believe, I'm inherently an optimistic person. I believe that while we know mining is generally destructive, you cannot dig a hole in the ground and not smash 100% of that thing that you're digging. You know, the space that you're digging is 100% destroyed. You cannot destroy it less than 100%. But surely we can do that in a more responsible way. And then, in that regard, I believe naively in the sapiens part, the sapientia, the wisdom part of Homo sapien. This is where the wisdom comes in. Surely we can realign mining, and I gave a TED talk of realigning mining with this wisdom. We can mine in a more responsible way. If we can move vast cubic kilometers of earth just to unlock a mineral, can't we place and deposit that in such a way that we can do something useful for it? And in fact, in one of the coal mining operations in South Africa, I proposed. This was a very, very big open pit mine. The pit would be in its final form something like 24 kilometers long. So it was a lake, basically. It would become a lake, an acid-producing lake. And I suggested then that just through the placement of the waste, can't we engineer an aquifer? Can't we engineer the waste pile in such a way that it can become useful after the life of mining? And the technical answer is yes, it can be done. It can be done, but you lack the will for it. You lack the. You can even justify it economically, because of the social right to mine, etc. If you can quantify that correctly, then maybe it costs a little bit more to place the spoil in a certain position, but it can be done. So we get down to this basic human condition, and that's called greed. If we're greedy and we want to maximize our profits for a minimum number of people, that is simply not sustainable. And so I keep getting back to that normative argument that I believe we can do things differently. I believe we should do things differently. I'm frustrated because I don't yet know how to do things differently. But that's where I am in my journey. It can be done. We can land a man on the moon and bring it back safely. We can do that. So we can dig a hole in the ground and we can make it sustainable. But we just don't want to do it. So that's the nut we've got to crack. And I think holism at least has got what I would call a fighting chance at survival. And I also believe, just in conclusion, I believe that when you communicate these things, there's psychology involved in communication. And if you communicate a negative message, people tend to shut down. They're not interested in hearing that negative message. So if you tell people that mining is ugly and it's not sustainable, they don't want to hear it. They don't care. They just don't care. They shut off. So you've got to position that message in a positive way, and that's the challenge. That's the challenge of the communicator. The art and the science of communication becomes very, very critically important in this context.
Yeah. Thank you, Tony. Thank you, Tony. That's why we call this phase 2 of the Holism Festival the liminal space, reimagining. And Mark, it'll be a quick one. Over to you.
Yeah, no, this is very quick. It is my studied opinion that trying to deal with greed and a lot of negative approaches to social situations is a fool's errand. And that the only chance we have, and this is not a naive, idealistic chance, it's a very grounded chance, is for people to work together to create things locally that work, and to think that you can directly assault greed is ridiculous. You can displace it. That's the only way you can get rid of greed, is have the population become more and more pro-social. And so people who, I'm not saying people shouldn't try to stop greed, but if you don't simultaneously create more generosity, actual practical generosity, where people are working together to do things, greed will win.
Mm-hmm.
Yes, I agree with you. That's a statement more than a question. Yeah, I agree with you. I mean, I've got no, I completely concur.
I loved your talk, by the way. I love to have a scientist, showing up with a bunch of holists. And so that my view of holism, you couldn't have been articulated better than your talk. So thank you so much.
So just
Well,
as a matter
when I was invited, when Claudius invited me, I was quite terrified, because I told him I'm not a scholar of holism. I've never ever studied it, and my connection to holism was actually through Smuts and my great uncle. My great uncle was Louis Botha. So Louis Botha and Smuts were both soldiers in the Boer War. They were both bitter einders, and they both went on to become quite prominent people. So I'm a direct descendant of Botha. In fact, I'll reach over here. This is an artillery shell here. See this artillery shell here? Can you see it? This is an artillery shell there. That comes from Botha. Botha's battery over the Ladysmith, the siege of Ladysmith. And the significance of both these gentlemen was that they were profound thinkers that came out of the Boer War, and they were both bitter einders. They both undertook to fight to the bitter end. And yet they both reached the realization in their life that to fight to the bitter end means that you will end up with a scorched earth, and it will be a lose-lose outcome. And in my own professional life as an intelligence operator, I was asked to take the bitter einde oath, a National Intelligence Service, also to fight to the bitter end. And so I'm a bitter einde like Smuts and like Botha was. And I also had to make that very, very hard decision about, if we fight to the bitter end, we're going to end up with the scorched earth. So that's how I got involved with, in creating the enabling environment to bring about a constitutional reform, that brought about a democracy in South Africa that eventually resulted in the destruction of the South African nation. But that's another topic. That's another matter, Nonetheless, so I'm inherently, intrinsically a constitutionalist. I believe in constitutionalism.
So, Anthony, I think it's about 3 o'clock in the morning there by you.
Yeah.
Thank you so much. Thank you so much for sharing your wisdom, your insight, your research, your knowledge, the graphic description of the hugeness of the existential challenges we face, and yet to hold the candle of hope that if we mobilize ourselves around holistic principles, holistic insights, even in our own local areas, as Mark was suggesting, then there's hope. And then to influence a new earth, as Glenn was saying. We've got a variety of topics that will be following through this year, looking at what the practical implications are. But yours has established the kind of groundwork that Glenn was talking about, why we need this deep collaborative international effort. And we'll be looking as we go forward at artificial intelligence, we're looking at food production, we look at human habitat, all of those things. Thank you so much for your contribution. And thank you everybody that stayed right through.
Can I just close by making just a short statement, please, if I may? Just a very short statement.
Yeah.
I had a privilege in part of my career of working with Mikhail Gorbachev. And I got to meet him personally. I met his family personally. I had dinner with him on a couple of occasions, and I met some of his advisors. And one of his advisors was a man. We had coffee together in Starbucks in Kyoto, believe it or not. And he was a rabbi, and a rabbi as an advisor to to Gorbachev. And he was a survivor of the Holocaust. He was left on the front doorstep of a family in Amsterdam, and much like Anne Frank, the same kind of Anne Frank story. And he was left with a family known as the Suttendorp family. And because I asked him his name, his name is Awiram Suttendorp, but he spoke Russian. And I said, that's funny, but Awiram Suttendorp, but that's not a Jewish sounding name. And then he said to me that as a survivor of a Holocaust victim, when he was living with the Suttendorp family, they brought him up as a Suttendorp, as a Christian, but they brought him up to never forget that he is in fact a Jew. And then he told me something, and this is my closing statement. He said that in his experience, a man can live for months without food, days without water, but not for a moment without hope. And I think that's the powerful concluding statement I would like to make. Our role here is to bring about hope, because there's the survival of the human spirit. It requires hope. That's the nuclear power, of this engine of sustainability is hope. Thank you.
And on that hopeful note, I'm going to hand over to Joshua to do the thank you.
I'd just like to thank you, Anthony, for sharing your life journey, for sharing your intellectual and scientific wisdom, and for giving us hope for the future. I think you and Glenn and so many others exemplify the deep kind of ethos of the Whole Earth Project. And what we're hoping to do is to link so many people together, so many networks together, to try and create a hopeful future in the face of the polycrisis that you described so graphically in terms of your talk. And thank you so much again. I personally appreciate your wisdom, and I hope that Glenn and you can connect and you can share your wisdom with the Earth Constitution Network. And I'll hand back to you now, Claudius.
Thank you so much. On that note, thank you for being up in the middle of the night. Thank you for those that have stayed through the distance. And our next presentation will be looking at the critical issue of our food systems against the context that has been described and how that can be done in a different kind of way. Thank you, everybody. Stay in touch.